All right. So in this video, we're gonna go ahead and create our project and then go ahead and implement our parser. So first things first, let's create a new project. And I actually already have one there, so we'll start over. And here we are. I think the very first thing that we'll do is create our WebAssembly text file. Test what? And let's go ahead and just steal what we had in the other one. And the other thing that we can do is look over here. Yeah, I think that we end up using a regex crate as a dependency just for doing our initial parsing of our input file. All right. And let's, yeah, go ahead and get rid of that. And I'm actually going to take these little boring parts and just paste the whole thing for now. So here we are basically just going to look at our input file and get rid of duplicative white space, and that's really all that is going on here with this regex parsing, which is not super interesting logic. And let's create our other files that we need. So we will need one for our tokens, and we will need one for our parser. And we can copy paste the tokens too. We'll go over all of this here in just a moment. And we're not going to need these bottom two. And that should be that for now. And yeah, let's go ahead and do this too. Okay, and we're going to run into an issue because we haven't implemented our parser struct yet. So let's go ahead and start off by doing that. So we're going to have a struct here, and it's going to be called parser. And the two things that our parser is going to take is the characters that we initially parse out of our input file, and then an index, which will represent where we are in the characters that we're in the process of parsing. So let's give that a shot, and looks like we are missing a lifetime specifier. For people who are new to Rust, lifetime parameters look like this, where we have a little tick and then another parameter. And basically what it's doing is it's saying like, hey, when we go and we implement this struct parser, or this parser struct, we need to make sure that the string that we use to define the cars attribute of the parser, this string needs to exist for the entirety of the time that the parser exists. Potentially the memory that is allocated for the lifetime of this string could no longer exist while the parser is still there, and then we would have bugs. So yeah, we need to basically say that we know that it will last for the entire duration of this string that we end up using. There are a lot of videos for people who are learning Rust that cover lifetime parameters, though they are notoriously a little bit challenging to think about. But yeah, so now we'll go ahead and we'll implement our parser. And the first thing that we'll do is we'll create a new function for creating them. So cars and we can do, this will return self. Initially, so the cars will be given as input, and our initial value for our index should be 0, and we probably need our lifetime parameter again. So, and actually, it won't know where that came from unless we do that. And what are we upset about now? Yeah, we should have it there too. Beautiful. So now if we come over here, I'm also going to do, actually, I think we're going to hold off on that for now. The next thing that we're going to do is implement an iterator trait for our parser, which is kind of an idiomatic way of handling something similar to a for loop in other programming languages. So let's go ahead and do that as well. So when we implement iterator, there are two things that we need, and we can actually look this up in the docs. Yeah, so we need an item and a next. So the item is kind of like the thing that is yielded from each iteration, and the next is like the logic by which we iterate. That wasn't a ton of detail, but I think that it should become more apparent as we go. So the first thing that we need to do is say that we have an item, and that is going to be a token, which I still have yet to define. So why don't we go ahead and define our token as well. So we need a type, or sorry, a struct token, and our token is going to have two things: a kind, and that's going to come from our token types defined over in our tokens module, and a value, which will be a string. Oh, and we need to use our tokens. Standard. Okay, and it's probably just, we still need our next. So then for next, and next we'll take a mutable reference to self, and it returns an option of our self item. Okay, so now it's upset because we aren't returning anything yet. So for starters, why don't we basically we're going to return something if there is still more iterating to do, and we'll know that when in a we'll do that until we return none. So we'll know that we're done when we've actually iterated through all of the characters for our parser struct. And so the way that we'll check that we're finished is we'll check the index and compare it to the length of our cars. So if self index is self cars, then we can return none. So this is what's going to happen when we're finished, and then our iteration will be finished. And now we can, otherwise, what we're interested is in looking at the car at the ith position. So here we can look at not that, but we're going to actually look from here to here. And let's just do something. Well, yeah, we'll start off with doing this. So how about if we encounter a open paren, the very first thing that we're going to want to do is make sure that our index is increased by 1, and then we will return some rather than none, and we have to return the token because the token is the item. So here we'll define a token, which has a kind and a value as defined above. So our kind here will come from our tokens, and so our tokens, why don't we go ahead and let's comment out most of this, and then we can worry about commenting them back in as we implement them. So the first one that we'll have is an open paren. So here that is tokens, token types, par, and our value will be, and you might be wondering, for people who are familiar with Rust, why we are using strings rather than our like string references or string slices. And basically later on we'll run into some ownership issues where I don't know, we don't want to spend a ton of time thinking about like lifetimes and stuff in this video. Want to focus more on the compiler. Maybe down the line I'll end up doing some refactoring, but for now our lives will be easier if we just end up owning things or yeah, making things a string. So yeah, let's see. Do we still see red somewhere? Yeah, so we also need to make sure then before we're able to fully do this, I'm going to actually, let's see. What happens if I do this right now? I don't think that this should work yet. So this collect is basically what would happen if we went through all of our iterating. And here it just doesn't know what we type we'll want to iterate into. So let's make this a vec of tokens. And actually that comes from a parser. Let's make it public. And we need to implement a debug in order to do that. And is my syntax not correct for that? I think it is. Oh, we just need to do the same thing for our enum. Okay, cool. And here we haven't handled all the cases for our match. So let's go ahead and say what we should do in the event that we're nothing other than that. And for now, why don't we just say that we're always a literal, and so that way we can get something printed here relatively soon. Also, totally put the wrong thing here. This should be L par, or actually L par. Okay, so then here, why don't we just do plus equals 1 again, and that way we'll make sure that we actually end up increasing our index long enough that we end up meeting this condition where we end up returning none, so that way our iteration does finish at some point. And for now, we can just pick an arbitrary token. I think that the literal one is kind of the most general, so I'll do that for now. Kind tokens literal. And in order for that to be recognizable, we will have to make that one of our options again. And we still need a value. And let's just go Okay, no red. Let's see what happens when we go ahead and run this. No such file or directory. I think that's because I need to change this. Okay, so what we are doing now at this point is iterating through all of the characters here. All of the white space has been removed, so basically we just know that anywhere that where we see a new line or a tab, all of that is just kind of treated as one space. And again, that was kind of glossed over here at the beginning, but we know for certain. Actually, I think that we could, if we want, we can print this just to make clear that that's what's going on. And so here we see the input, which is our characters. I could have put a new line in between our print statements, but that's all right. And so basically we just see all of the text kind of as though it was on line. All right, so we're going and we're iterating through this string character by character, and then parsing it, or recognizing that it is a token that like semantically is operating as one of the recognized tokens which we enumerate in this list over here. Yep, let's basically at this point we can kind of just go through and implement everything. So right now you'll notice that for our parsed tokens, it's recognizing the first one as a left parenthesis, and then it's counting every other character. It's identifying every other character as a literal token, as foo, except for every now and then it will encounter another left parenthesis, and it knows how to correctly define left parentheses. Why don't we go ahead and do right paren, which should be basically exactly the same as a left paren. These are kind of the two easiest ones. We can call boom and all right. And again, it doesn't know about right parentheses yet. Okay. We need one other one, which will be space, and then after that, all of our tokens have a greater length than one, which is where our scanning gets a little bit more interesting. But for now, let's go ahead and start with let's implement what we do for a space. So here, if we encounter a white space character, we will just do self.index plus equals 1, and we can return self.next, which is the function that we're doing right now. So basically we kind of just skip over white space, and it's not really significant. And so now let's do this again and see how these things look now. And we have lpar literals, and we basically should see literals until, let's take a look at our actual input. So we basically everything until we see another left paren here. So however long module is 1, 2, 3, 4, 5, 6 characters, and then another open paren. And here indeed we have our next open paren. And if we go down towards the bottom, we should see that some of the final things are right paren. Yep. So now let's talk about what we're going to do for our more general tokens. So here, instead of classifying everything as a literal token, let's go ahead and let's just start off with module. So if we see module, then basically we can do, well, hang on. So basically, trying to decide the best way to go about doing this. Well, we basically, if we're scanning module, at one point we'll be scanning M, right? And so we don't know at the beginning of this word at the beginning of this token whether M is going to end up being a keyword like module, or whether M is going to end up being something like the name of a function, like over here where we have add to. This could be just phenomena, or any string. So what we need to do basically is kind of find a way to look at, like, peek at the next characters, so that until we hit the end of it, and then basically once we encounter either white space or a closing paren, then we'll know that we are done scanning the current token that we are in the process of scanning, and then we can check whether it's one of our keywords or not. And if it's not one of our keywords, then we can go ahead and assume that it's a literal value. So why don't we, while we're over here, comment out our module and make our way back over here. So I think I'll also just go ahead and do this. And we'll say that our token length by at the beginning of this will be 1. And then we'll do a loop. We can go ahead and get rid of this for now. And so our loop here, let's bring these up, and this is where our actual match is going to be. So we'll match on all of the characters that are in between the current index and the current index plus the length of the token. So basically, the next number of characters that we look at will be from the index forward, whatever we've measured the token length to be. And if this slice of our characters is one of our keywords, then we're done scanning. Otherwise, we continue to go until we reach a character that signifies that we're likely at the end. So as an example here, self.index plus equals token length. So in this case, plus token length. So in this case, 1, 2, 3, 4, 5, 6. Our token length would be 6 because we've already gone through our loop, say 5 or 6 times. This should hopefully be a little bit clearer after we're done writing our loop. And then basically all of these characters that would come from doing this slice would be the string module, in which case we break out, and our token is going to be, in this case, again, it's going to come from our enum, and here our value is going to be, again, a string from, and we'll just call this module. And so here that's what we'll do in that case. This one is the more interesting one. So this would be like when we're currently, but if our token length starts off as 1, we move forward 1, and we have M, and then we'll end up going through our loop again. It's only MO, and then we'll go through our loop again, and our token length is 3, and then our match statement will be MOD, right? So we're going to basically keep iterating that way until that's not right. Sorry. Yeah, actually that is right. So until the character that is whatever number token length is that much further than our current index, until that is either equal to a closing paren or is equal to white space. That is, so when that is the case, we'll know that we're done. So then we can basically let our token be a literal. And our value will be what we've been matching on all this time. But we also need to do that string from. And let's see. I think that should do. We need. And then once we have that, we can go ahead and do self index. So now we've gone through a token length worth, just as we do like over here on line 45. We need to skip the index forward, as long as this actual token is, which in this case is 1, 2, 3, 4, 5, 6. Over here, we need to do just whatever token length is, which is not predictable because there's no way to know how many characters it will take in order to reach a closing paren or a white space. And then we can break on our token. Right. And in the event that we didn't reach a terminal character, like a closing paren or a white space, then we, it might have been just MO or MOD, in which case, our token length needs to increase by 1. And we need to, see if, go and check again whether or not we matched one of our keywords, which will define more other than our module, or whether we're just done. So let's see what happens if we do this now. And of course, we forgot our plus equals. Let's give that another shot. Okay, so we see here that we have our L par and let's go ahead and just look at this again. So we had note our left paren, then we correctly identify module, and then we correctly identify our next left paren, and then we're basically seeing func and identifying it as a function. We then have identifying it as a literal. So instead of recognizing it as, this is a function definition, it thinks that we're encountering a name like add2. Similarly, we basically keep doing that. The one issue that we do need to fix before we move on to classifying the rest of our keywords is right here. These literals, it looks like we have quotes in here and it's trying to escape our quotes. So I'm going to add something right here. Let's see, just to get rid of those, so we can do a dot replace, and let's see, this should work. So I'm going to copy and paste this. And something's not right here. Let's see. Let's try that one more time. Oh, silly. Because we don't want to replace that on our token, we want to replace that on our actual string, which ends after this paren. Okay, so now if we go through and we do this again, we see add to looks the way that it should instead of having those backslashes in it. And after that, the rest of this should be fairly straightforward. We've done kind of the hard part. Let's just go through our enum and handle the rest of our keywords. So next one is func. And I think we should actually be able to just copy our module logic and replace module with func. All right. And indeed, now it recognizes func as the func keyword. And yeah, the next one that we encounter is going to be export. And at this point, this is kind of pretty prescriptive what we should do. Actually, there is a little bit more that is a little bit interesting. I think that when we handle our params, we'll have an unknown number of params, so that should that'll be something that isn't as predictable. But 1 second. This might be a little bit confusing, but 1 moment. So we have a difference between a param and a param declaration. Over here in our, basically a param declaration is the keyword param, and then each of these are actually going to be a param in our enum, a param token whose value is I32. So let's go back over here and talk about what we should do in the event that we're looking at an I32. And so here, actually, I32 can be encountered in 2 different ways. We'll sometimes see I32 followed by a dot, and we'll sometimes see I32 on its own. So we'll need to handle those differently. So first, why don't we just go ahead and check which of those we have. And then basically, so if the next character after our I32 is a dot, then we know that we're not done scanning our I32, and that we actually just should increase 1 to our toke length and continue to scan. So here, this will just be toke length plus equals 1, and we will continue. Otherwise, our index should move forward by our token length, and we can do our familiar break statement. And here we are a param, and our value is an I32, and we need to comment out our param. Looks like we've only got 3 left. What was our next one? Result. And actually, I think a result is another simple one. So let's go ahead and just copy from up here. And let's just go ahead and comment everything out at this point. And result. Let's see, our next one is our local get. And our last one is an I32. Our addition. And what do we call it? Okay. And so now if we go ahead and do a cargo run, we see our parsed tokens over here, and it should match basically all of the things that we have. So first we have our left paren, then we see our module, another left paren, a func, another left paren, an export, and then we have our first literal, which is adding 2, and so on and so forth. And basically all of our tokens are being measured correctly. We can identify semantically what each character is doing. In our next video, what we'll do is we will go ahead and we'll construct an abstract syntax tree from our tokens. So we'll iterate through our tokens, and then we will identify how they relate to each other grammatically, and then in the video after that we'll traverse the abstract syntax tree that we have and omit WebAssembly bytecode as we do it. So yeah, thanks for watching this video, and looking forward to seeing you all in the next one.